Hello. Today I'm going to solve my version of problem 5 in set 11. It's set about low decks, about linear, homogeneous ODEs with constant coefficients. And here, this is an initial value problem. This is a pretty hard one, and actually you are going to need to use the quadratic formula on this. I put at the top here the facts that we need from pre-calculus and calculus. The derivative of e to the t is e to the t, e to the 0 is 1. Derivative of cosine of t is negative sine of t. Cos of 0 is 1. Derivative of sine t is cos t, and sine of 0 is 0. So that's really what you need to know from pre-calculus and calculus, plus a lot of algebraic skills. So let's go right in. Here's the differential equation. It has constant coefficients. It's homogeneous, 0 on the right-hand side. It's linear. Have an initial value problem with those initial conditions. All right, so remember we plug in y is e to the rt, and that gives us 25r squared plus 90r plus 130 equals 0. That's the characteristic equation. All of these have a factor of 5 in them, so let's just divide through by 5. We get 5r squared divided by 5. We get, I think, 18r plus, I have it written down here, 130. Right, plus 26 equals 0. All right. So maybe there's some people I've seen factoring these things, they do something like that, but I really don't know what that is. People, I don't know. So I just, if I don't have a 1 there, or if I don't have a 1 there, I usually just go straight to quadratic formula. So we have r is going to be negative 18 plus or minus square root of 18 squared minus 4 times 5 times 26 all over 2a, which is 10. You might need a calculator. I got minus 18 plus or minus square root of minus 196. Whoa! Over 10. Right? You can't take the square root of a negative number if it over the reals, but this is going to be an I, and a pure imaginary number, and you might remember that 14 squared is 196. So R is negative 18 tenths plus or minus, what is it, 14 tenths I. All right. Or I might want to write this, so I might want to write this as negative 1.8 plus or minus 1.4i, or I might want to use minus 9/5 plus 7/5 I, plus or minus 7/5 I. All right, so this decimal point, actually when I plug in the answer, I can use the decimal points. And when I actually do the calculations, I'm going to use fractions. So here in our formula, A is negative 9/5 and B is 7/5. This is the roots of the characteristic equation are A plus or minus IB. And I like to write A plus or minus IB, but then I write A plus or minus BI if B is an actual number like 7/5. All right, so that means that we're ready to write. The characteristic equation is no longer needed because we're ready to write the general solution. Y is C1 e to the minus 9/5 t. Now that doesn't look good. Times cosine of 7/5 t plus C2 e to the minus 9/5 t sine of 7/5 t. All right. And I think it's probably convenient. It's going to be easier to differentiate if I factor out the exponential factor. So I have e to the minus 9/5 t times the quantity c1 cos of 7/5 t plus c2 sine of 7/5 t. All right. So what is, and let's remember this is really y of t. And that's going to be useful when I plug in y of 0 as a. But let's first compute y prime of t, right? I got to differentiate the function of t. All right, so I'm going to have derivative of the first times the second plus the first times the derivative of the second. So I get negative 9/5 e to the minus 9/5 t times the second, c1 Okay, so when I said that's all you need to know about calculus, I was definitely exaggerating. I'm not done yet, but I'm using the product rule and the chain rule here. Now, okay, so that's a derivative of the first times the second plus the first, e to the minus 9/5 t, times the derivative of the second, derivative of cosine is negative sine. So I have a negative 7/5 c1 times sine of 7/5 t. That's the derivative of this term, bringing out the 7/5 from the chain rule, the minus sign from that. All right, and then I have the derivative of this term. I'm going to get 7/5 c2 times cosine of 7/5 t. Sitting in there. All right. Wow. Okay, so let's use the initial conditions. These imply that, well, y of 0 from the formula, that's going to be it looks really complicated, but right, e to the 0 is 1, cos of 0 is 1, sine of 0 is 0. So y of 0 is just c1 when all the dust settles. And I'm going to set that equal to 6. So we've got half the coefficients already. And I put the break here because there's 0 times c2. And then y prime of 0 is going to be a little bit more complicated. Y prime of 0. All right. I'm going to get a minus 9/5 from here times 1 times c1 times 1. That's c1 plus c2 times 0. And then I'm going to get a plus 1, so I don't have to write, times something times 0 plus 7/5 times 1. Well, I don't even have to 7/5 times c2 times 1, because cos of 0 is 1. And that equals 1. So I'm going to circle that, not that that's the end of the problem, but that is sort of a place to take a breather. Like right now, I could go get a snack or something, right? Because now all I have to do is solve this system of two equations, plug it into the general solution, and I'm done. All right. Okay, now after I've had my snack, we're back. Well, the first one is easy. C1 is 6, right? So let's take this second one with C1 is 6, and I get minus 9/5 times 6 plus 7/5 C2 is 1. That's 54. I get minus 54/5 plus 7/5 C2 is 1, or 7/5 C2 is going to be 1 plus 54/5. That's 5/5 plus 54/5. That's 59/5, right? Wow. So 7/5 C2 is 59/5. So just multiply everything by 5, and I get 7 C2. I'll go over here. And maybe I'll go in here. We get 7 C2 is 59 or C2 is 59/7. So I get C1 is 6, C2 is 59/7. All right, we're almost done here. This is going quick for me, but I have to tell you, it took me 20 minutes to find out my errors in doing this, and it'll take you at least that long, I suspect. All right, so the real solution is y is 6. I erased a nice formula with the exponential in it. Oh well, let's put it back in the nice formula of the exponential. I get e to the minus 9/5 t times C1 cos 6 cos of 7/5 t. All right. And then plus 59/7 sine of 7/5 t. All right, cool. All right. And that is, I'll circle that because that really is the final solution. Okay. And my sevens sometimes have a little tail on them. Okay, good. And when I type this in, I may want to use, like 1.8 for 9/5, 1.4. In fact, I've got this. Let me share the screen just to see. I don't have where are we here? Here. Oh, shoot, I must have a Desmos somewhere. Here we go. I think I've already got it. Here it is. And then like on this thing. All right, so actually let's see if we can barely see it here. E to the minus 1.8 t, good, times 6 cos 1.4 t plus 59/7 sine, and then what's the rest of that? Oh shoot, oh well, it's gone. But anyway, that's the right answer. I've already done it before and checked it. All right, see you.